Here is the schematic to the SCR Triac checker that you will see the features of in the remaining part of this video. At the end of the video, it will also show how to check an SCR. There will be two separate videos using this particular test setup, one on SCRs and one on Triacs, and what to look for. Very simply, I have a 25 volt isolation transformer, a potentiometer to control gate current on either a Triac or an SCR. There's a diode here when you want the positive half cycle to test the SCR. You have a switch, which is really just a jumper. When you're checking Triacs, this switch must be closed and you must bypass the diode. The load is a 24 volt little incandescent lamp, and across that load is a digital voltmeter. You will get different responses on the meter depending on whether you're using a Triac or an SCR, and that will be explained in the other videos and a little bit at the end of this when it demonstrates pulsating DC. And of course there's a Diac also built into the system. It's part of, this is more of a home-built laboratory exercise, and these are the components you're going to need. This is how I set up the Triac and SCR checker. There is a 25 volt transformer off to the side, comes in back here. It consists of this zero insertion force socket, this control board, and I use a digital voltmeter. The load is a light bulb. The voltmeter leads are connected across the light bulb, and we can measure AC or DC to understand the properties of the SCR or Triacs that we're trying to check. The light bulb will light up. Like I said, you can put in Triacs down or SCRs down here in the zero insertion force socket. This also has a socket built here that I happen to have from an old television that you can plug the device, if it's a TO220, right into the board. If you are dealing with this kind of SCR or Triac, I built this little plug-in cable with 3 plugins, and the colors are here for a reason. The red lead goes to the anode on an SCR or T2 on a Triac. The black goes to the cathode of an SCR or T1 on a Triac, and the yellow always goes to the gate. In addition, there's 2 small jumpers and a potentiometer. The potentiometer controls the voltage being fed to the gate. There is a jumper with a diode here. You can use a diode to just take the positive half cycle of the AC to trip on an SCR. Out here I got a jumper across a Diac, and I will discuss in 2 separate videos now how to test both. This video is simply the introduction to the device. Then I'll make 2 separate videos on checking each individually. Let's observe what happens with an SCR. The meter is set for DC, if you can see that. The power is off. I'm going to plug in an SCR. An SCR, when turned on, of course, acts as a half-wave rectifier. So when I trip it on, all I'm going to do is get pulsating DC.